Hey y'all, it's Miss Johnson. Welcome back. Happy New Year. Um, we're jumping into it. 2021, year of calculus. All right, so the first assignment we have this year is talking about derivatives, remembering what they are, remembering what they do, remembering why we care, and remembering what we know what to do with them so far, right? So I'm going to go over the first three questions with y'all, and then I'm going to do some examples that look like the questions on your assignment, and then you'll do the actual assignment yourself. Let's get to it. So what is a derivative? Is it a number? Is it an equation? Can it be both? What does it mean on a graph? What's going on? A derivative is a way to represent the slope. And this can either be at a specific point, so that would be just a number, right? Or it can be in general, which is a slope equation that describes how the slopes of an equation act, right? So this would be an equation. It means on a graph, it's the slope, it's the rate of change. Rate of change. And generally, it's the rate of change. We care about derivative when it's not constant, when it's not a straight line. So when we have a curvy line, when we have exponentials or polynomials or whatever, when we want to talk about their slope, we generally need to use the derivative because it's more complicated than just saying it's getting bigger. What can we use the derivative function for? We can use it to find the slope at a specific point, right? One of the things we'll also learn how to do is we'll learn how to maximize and minimize functions using the slope. And just as a preview, we're going to talk about this more on Friday, but the kind of max and min of this function is right here and right here. And you might notice that at both of these points, the slope is equal to 0, right? So we can use the derivative to find when the slope is equal to 0, and then we can say, well, when the slope is 0, usually we have either a maximum or minimum, and now we can start to zero in on where functions are highest or lowest, which is kind of dope, kind of powerful. And then what is the power rule for derivatives? The power rule for derivatives is if we have a function that looks like this, then its derivative is multiplying the coefficient and the exponent, and then kicking the exponent down by 1. That's the mathy version. Math. The kind of explanation version is you take the derivative of a function like this by multiplying the coefficient and exponent to make your new coefficient. And by subtracting 1 from the exponent for the new exponent. As always, these notes are posted on Schoology if you want to read through them later. But yeah, again, I just said the same thing I said while I was writing down the math version, which is you take the derivative of this function, this a times x to the power n, by multiplying the coefficient and the exponent, so the a and the n, to make your new coefficient. That's the new number out front. And then by subtracting 1 from the exponent for the new exponent. Great, let's see it in action. Right, we just said, again, the plan is multiply these two numbers for this, and then knock this down by 1 for the new exponent. So when we take the derivative here, we say what's 2 times 10? It's 20. And then what's 10 minus 1 is 9. We do the same thing here. 3 times 8 is 24. 8 minus 1 is 7. Negative 4 times 6 is negative 24. 6 minus 1 is 5. Bingo bongo. That's the computation side of it, right? The computation side is literally being able to take the derivative. The interpretation side of it is like, what is this blue function, right? This blue function is at any point on this equation, this gives you the slope at that point. This is the equation that if I wanted to say, what's the function value at 0? I'd plug in 0 and get 0, whatever. What's the slope at 0? I'd plug in 0 to this blue function. I'd also get 0, but, it's kind of fun. Next example. We're going to say the derivative is 20x plus 8 plus 0. I went kind of fast. Let's explain. 10 times 2 is 20. 2 knocked down by 1 is 1. Bingo bongo. Here, we could do the computation side of it. We could say that this is the same as 8x to the power of 1 plus 13x to the power of 0, and then do the actual power rule. But I would much rather memorize that this portion is linear, right? This portion is in mx plus b format. So the m is going to be our slope. And this part isn't going to give us any slope at all. So it goes to 0. And we talked about this in class as well, where linear things give you the slope and constants give you nothing. Slope derivative, because slopes is derivative. So here I would write y prime as just 20x plus 8, because I would lose the plus 0. All right, 2 more examples that I want to go over. What if the coefficient is negative? Same thing. We just do the exact same thing. We do negative 8 times 5 is negative 40, and this becomes a 4. And then negative 3 times 4 is negative 12, and this becomes a 3. No problems. And then you might say, well, Ms. Johnson, what if the top is negative? What if both of them are negative? The rule stands. These could be fractions, these could be decimals, these could be irrational numbers. The rule always stands. So we just get to follow that every time. We get to say this is negative 60x to the negative 7, because negative 6 minus 1 is negative 7. This is negative 15x to the negative 4. Again, when we knock it down by 1, we do negative 3 minus 1, which is negative 4. And then negative 8 times negative 7 is positive 56x to the negative 8, because negative 7 minus 1 is negative 8. That's what we got. Let's do this assignment. Let's remember how to do derivatives. I am going to post an additional video about the note-taking sheet that I want us to do, and that's going to be in the notes folder. But for right now, let's work on the assignment. All right, come to office hours or email me if you have any questions.